we're looking at example number 2. I'm going to write it out here. It is 6 to the power of 6x. Oops, that's a little bit big. Let's see if we can find something smaller. 6 to the power of 6x multiplied by 9 to the power of 3x divided by the following, which is 54 to the power of 4x multiplied by a quarter to the power of 2 minus x. Okay, so what I want you to do is remember we're going to get this into prime factor bases, and we're going to find the easiest ways possible to do that, right? When we are dealing with simplifying one-term exponential equations, remember there were 2 steps. The first step was try to factor each of the bases into prime factors, and then you want to apply the exponent laws. So in our particular case, we're going to look at 6, 9, and 54, and we're going to try and prime factorize them first. Okay, so there's 6, there's 9, there's 54. Now there's an easy way to do this on the calculator, which is not what we're going to do over here, because we assume that you've done the mechanical way to say that this is 2 multiplied by 3. This over here is going to be 3 to the power of 2, and this over here is going to be 2 multiplied by 27, and 27 is going to be 3 multiplied by 9, and 9 is going to be 3 multiplied by 3. Okay, and so we can clearly say that is going to be prime factorized into 2 multiplied by 3 to the power of 3, right, which is 2 multiplied by 27. 2 times 3 to the power of 3. And that's the prime factorization of 54. Okay, so remember that there's an easy way to find this on the calculator, and I've actually uploaded a separate video that shows you how to do that. Okay, so let's go one back. Just a very important note, the calculator will not be able to look at 1/4 and put this into prime factor basis, because prime factorization is looking at exponents that are essentially natural numbers. And when we look at this thing over here, this factors, I mean, if you want to put this in a prime factor base, for example, 2, this is 2 to the power of -2. How did I get that? It's actually, I've looked at 1/4, and 1/4 is equal to 1 over 2 to the power of 2, and then remember this here, I can simply simplify into 2 to the -2, and that's how I get that. So the calculator won't allow you to use its factor operation. On the calculator will not be able to tell you that this is 2 to the -2. So it's very important that you actually know your exponent laws quite well, and being able to factor the 4 into a prime factor base. Okay, so let's go back to the actual question over here. As you can see that is 6, and we already said 6 is equal to 2 times 3. So what I'm going to do is I'm going to simplify that and make that, I'm going to change the 6 into a number that is 2 multiplied by 3 to the power of 6x, right? And I'm going to multiply that entire thing by 9, which is 3 to the power of 2 in prime factor basis, raised to the power of 3x, and then I'm going to divide that by the following. 54, which we've just learned, is 2 multiplied by 3 to the power of 3 raised to the power of 4x, okay, multiplied by 1/4, which is 2 to the power of -2 to the 2 minus x. Okay, so let's see how we can simplify that. And let's do each part, right? Let's start with the first one. When I need to apply the exponent law. The exponent law is a very easy one that we're going to use. We're actually going to use this law over here. This law that says if I have a to the power of, let's make it m, and b to the power of n, and I raise that to another power and I call that power b. Let's not use b, let's use p. And this is equal to a to the power of m times p multiplied by b to the power of n times p. And let's look at a quick example. Let's just put in values for all of these. Let's call a 2, and let's raise the power to a 3, and let's make b 4 and raise n to the power of 1, and then let's put a power there and make that 2. This is going to simplify into the following. We're going to say, well, put the base there, which is 2, and then we take the 3 and we multiply it by 2, which gives me 6. And then I take the 4 and I say 1 multiplied by 2, which is going to give me 2. So the rest is fairly trivial. You can solve that. Where you first take 4 to the power of 2 and then 2 to the power of 6, and then you multiply them to get your answer. So that's exactly what we want to do over here. We want to take 2 to the power, that's to the power of 1, and we're going to say 1 times 6x. That's going to simplify into the following thing. It's going to give me 2 raised to the power of 6x, multiplied by 3 to the power of 6x, multiplied by 3 to the power of 2 times 3x, which is going to be another 6x again. Okay, divided by 2 to the power of 4x, multiplied by 3 to the power of 12x, okay, 2 to the power of 4x, 3 to the power of 3 times 4x, 3 times 4x is 12x, multiplied by, now this one gets interesting because we got to take the minus 2 and we got to multiply it by this entire exponent. So I'm just going to do that on another page, and I'm going to say that is minus 2 times 2 minus x, minus 2 multiplied by 2 minus x, and for this you simply need to FOIL it out. If you do that, you're going to get, ooh mama, you're going to get, ooh, minus 2 times, okay, my arrows are just not lining up today. Minus 2 times 2 is minus 4. Negative times a negative is a positive, and 2 times x is just 2x. So it's going to be minus 4 plus 2x if I multiply those exponents. So let's see what we get over here. This is going to be 2 to the power of, and let's just get the black pen again. It's going to be 2 to the power of minus 4 plus x. Okay, now that's a very important thing to note over here. 2 to the minus 4 plus x can also be broken up. And before I continue, I'm going to show you how do we break that up. 2 to the minus 4 plus x. Let's see, what if I had x to the power of 2 multiplied by x to the power of 3? You'll say, well, Imad, that's just x to the power of 5. Now, how do you know that? You know that because that's actually equal to x to the power of 2 plus 3. What I'm trying to demonstrate here is that if in the exponents there is addition, right, then you can always break it down into the following. Same base, 2 multiplied by another 2, and the exponents will just be the individual terms of the exponents above. So that's 2 to the minus 4, and that's going to be 2 to the power of x. Do you see what I mean? In the very same way, if I have x to the power of a multiplied by x to the power of b, that's equal to x to the power of a plus b. If I see any addition, I can always break it down to just putting the same base and then just putting each of the exponents on their own. And that's exactly what we're doing over here. So if I had to give you 3 to the power of 4 plus 5, you could say, Imad, that's just 3 to the power of 4 multiplied by 3 to the power of 5. Do you see what I mean? If I've got a sum, if I've got the adding of exponents in the exponent or the power, right, adding of values over here, I just break it down, put them all on the same base, multiply the bases out, and then you put the individual exponents over there. It's really the reverse of the product rule for exponents. Okay, it's the reverse, or working backwards, of the product rule for exponents. So let's go back to the question, and let's do that over here. Let's break this down and say, okay, that's going to be the following. That's really going to be equal to the denominator over here. I'm going to simplify the numerator. I'm going to say that's going to be 2 to the power of 6x multiplied by same base. So all I do is I add the exponents, and if I have 6 cows plus another 6 cows, or 6x's plus another 6x's, it's going to give me 12x. Okay, and then I want to divide it by the following, and I'm going to say, okay, let's take all the same exponents. I could simplify this and break it down further, or I could immediately say that 2 and 2 is the same base. Let's add these bases together. Let's add the exponents together where we have the same base. So as I can see, I clearly have a base of 2. I'm going to say 4x plus another x. is going to give me 5x minus 4, right? Multiplied by 3 to the power of 12x. Now, another important rule, I'm just going to pause over here. A very, very important rule is the following. If I have a times b over a, then I can cancel. Only if I have a factored expression can I cancel. I cannot cancel out terms in a numerator in a denominator if, for example, I have a plus b over a. You cannot cancel like this. Cannot cancel terms. Right? Like this, because this is not valid. Okay, so it's very important that a person is able to see that, right? But because this is factored, this is something multiplied by something else, and something times something else, I'm actually permitted to cancel like that. Okay, so now we're going to simplify this even further. We're going to say that's 2 to the power of 6x, and we're going to use that law that I briefly spoke about. I said if I have two different things that I add up over here, then I can say that's going to be 2 to the power of 5x, right? Oops. Multiplied by 2 to the power of negative 4. Okay, I see a slight error. And I'm so ever sorry. When we multiplied this out over here, and let me just use a red pen and correct that. This over here, I had to multiply minus 2 times 2 is minus 4, and minus 2 minus times a minus is a positive, and 2 times x is going to give me 2x. So that's an error. Let's just fix that one quickly. That's going to be plus 2x. Now we're going to say 4x plus 2x. This is supposed to actually be 6x over here. Let's just fix that. This is very reckless of me. But the point is, if we have the mistakes in the videos, it's good because hopefully you pick them up. And then this over here is also going to be 2x. And so hopefully you've noticed that, right? And now you can see exactly something times something and something on its own over there. That's fine. It means I can cancel this out. Right? And therefore I'm left with 1 over 2. This leaves me with 1 over 2 to the minus 4, which is just equal to 2 to the power of positive 4, which simplifies to 16. And so that is essentially example number 2. Alright, be sure to go over all the laws that we've actually used in this application. A question like this is worth quite a few marks in grade 11 or even grade 12.